Welcome to a lesson with Dr. Powell. Let's take a look at how we could find the number of cosets that happen when we look at free Z module Z2, Z cross Z, and we mod it out by the span of a couple tuples. Maybe we can do that times Z. So let's do the span of let's say maybe like 2, 3, and maybe like 1, 4. Okay, so let's do the span of these in here. So this is a subgroup, and this right here is the quotient, and it represents the cosets. Question is, how many cosets are there? Well, kind of one thing that we can do is we could actually do some row and column operations to see this, to find out exactly what that is. Reason why is we're looking at two vectors. So 1, 4 coming up. Okay, so 1, 4 coming up here, and another one, 2, 3, maybe over here, somewhere like this. And basically, what we're looking at is we're modding out by this. So that means every time we add by this or multiples of this, we get the same thing. So this point's the same as that point, same as that point. This point is the same as this point, same as this point, and then you kind of have this whole grid. So really the cosets all have representatives right here in this shape right here. And counting that is equivalent to really like even computing the area, if you will. But also kind of Smith normal form provides another way of thinking about this in terms of sliding. We're just going to do isomorphic operations to slide the picture so it looks like a rectangle, and it's easier to decide what to do. So that's exactly what we do here. And it doesn't really hardly matter which way we do it. But in terms of rows or columns, let's do 2, 3, 1, 4. Okay. So Smith normal form, we can interchange those. So we get 1, 4, 2, 3. So we have a 1 in this corner. And you can use this 1 to play, well, get rid of this 4 here to play against that. So -4 there, you get a 0. And -4. So -8 and 3 would be -5. And then you have a 1, 2. Now this can really just clear that out. So you have 1, 0, 0, -5. Okay, notice when you look at this, what does the picture look like now? Okay, well, you think things have changed. We were doing columns, so we'll just stick with columns. So here it looks like we're going over here to 1, 0, and up here, and actually we could just flip-flop this. Maybe we can multiply by -1. Multiply by -1 to make that a 5. That would be okay. Now, at least for integers, there's not really anything more we can do with this Smith normal form, because we can't divide by 5 because we're working just in the integers. We're not working in a field. But that's perfect, because sliding, that's exactly what we wanted, because these isomorphic actions don't give us more cosets. If we multiplied, we'd be making this area larger. So we wouldn't want that. We want to keep the area the same, and that's perfectly fine. So here, now we go 0, 5, which is up here. So really, all the cosets are just contained in here. And notice, since this is the same as this, we just take one side. So right here, 1, 2, 3, 4. So let's say 0, 1, 2, 3, 4. Okay, but we don't want to take the top if we've taken the bottom. So really, we have 5 different coset representatives, and they're all right here. We can see them very nicely. So, and in particular, with modding out and going and repeating, even on this line here, every 5, and this way, really, it seems with 5 things and 5 different cosets and chunks, you can even check the arithmetic. It's going to be like mod 5. Think about it. If you take 1 and you add it to 4, you're going to get 0 again. So this is going to be isomorphic to Z mod 5Z. And how did we do it? We did it by simply doing row and column operations. Thanks for watching.